Revisiting the topic of data science notebooks utilized with Snowflake. I have on screen a Databricks notebook, which you've seen before, but in this video, we're going to go just a bit deeper into the integration capabilities and some functionality relative to Snowpark. So first, I'm going to draw your attention to my compute profile here in Databricks. I have configured a compute cluster that is as small as it can possibly be. Databricks version 10.4, long-term support, 4 cores, 14 gig of RAM. As you probably know, in order for this notebook to do anything, we do need to have this compute running. So you think about that in the context of cost. If you were going to be analyzing large data sets in Databricks, you very likely need a compute cluster far larger than this, and that compute cluster would be running during the creation, manipulation of the notebook, which arguably equates to unnecessary cost for most of that activity. So in this case, by choosing the smallest possible configuration, we minimize that cost on the Databricks notebook processing side of the equation. So I'm going to go ahead and start this. It'll take a couple minutes. I'm going to let this process run just so you have a feel for the length of time it takes for compute to start, as that data point is relevant to some things we'll show later in the demonstration here. I will include timestamps, so if you hover over the timeline down at the bottom of the video, you'll be able to fast forward if you need to do that to get to other parts of the demonstration. But this starting of compute, starting of Spark, attaching compute should take 2 to 3 minutes, but we'll go ahead and let it run. Pardon the silence. And again, timestamps down in the timeline, feel free to use those to fast forward. As this progresses through the process of starting, it's kind of interesting to think about what it would take, what it would require if you needed to scale this compute up in order to meet the demands associated with your particular data set. My guesstimation is that it would take quite a bit of time to reprovision, restart, attach, etc. All right, should be almost there. Starting Spark. All right, cluster is now running. We'll go ahead and get to work. I think that was just about 2 minutes. Okay, so what does it take to utilize this Databricks notebook with Snowflake and Snowpark? Pretty simple. The version 10.4 of Databricks is includes the Python 3.8 runtime, which is currently required for Snowpark. So we're in good shape there. And we're going to go ahead and pip install the Snowflake connector first. Python interpreter restarts as a part of that process. All right, connectors installed. Now we'll go ahead and pip install Snowpark with pandas support. Go ahead and run that cell. Okay, that's now installed, and now we'll get to work. So here I'm going to create a dictionary with my authentication credentials for Snowflake, and I'm pulling those credentials from an Azure vault. Go ahead and run this cell. That has run to completion successfully. I'll go ahead and import the Snowpark session and functions modules, and then I'll go ahead and create a session. So now I've got a session to Snowflake with my default authentication credentials. I happen to have a table in the default schema for this account called raw point of sale order detail. So we'll go ahead and get some information that table, print it out. We can see it's a Snowflake table, and let's go get a record count on that table. So we have, what is this? 673 million records in this table. Should be sufficient for a demonstration. All right, go ahead and show some of the contents of that table. You can get a feel for what that looks like. And again, we can use that session to do some interesting things. Given the amount of information contained in this table, I want to increase the scale of my compute. What we're demonstrating in this next cell is the ability to provision compute on the fly. Create a replace warehouse, give it a name. It's going to be a standard warehouse, and I'm going to create a XX large and set the auto suspension for this to be 120 seconds. So if it is idle for 2 minutes, go ahead and suspend the compute. Go ahead and run that cell. And in 0.22 seconds, we've now created scaled or additional compute for this session. I'll next go ahead and set this new warehouse as the warehouse to be used for my session. And then I'm going to run a quick join here. Go ahead and run that cell. It's now complete. Get a count of the data frame. And again, you see that 673 million records. Go ahead and show that. Get a feel for what the data looks like. We can also take a look at the schema for the data frame. Now I want to create a new data frame with a subset of columns from my previous frame. I'll go ahead and do that in the next cell with a simple command here. Again, specify the data frame as you might expect with my Snowpark session being a view into the data as it sits in Snowflake. I have a function called column that I'm going to pass to the data frame in order to pull out the columns that I want to be in this new data frame that I'm creating here. So we'll go ahead and run this cell. And now my new data frame with a subset of columns and those 673 million records is now created. Go ahead and get a count on that, as well as have a look at the schema. You can see that this is all really, really quick, really responsive. Go ahead and show this new data set or data frame. You can see that my subset of columns exists. We will go ahead and run another query, again doing a join, and that's now complete. Again, the speed at which this comes back is a byproduct of the lazy execution model implemented by Snowpark. Again, get a count on this data frame, and that's our 673 million records in yet another data frame. Go ahead and show those as well. And if I wanted to, I could go ahead and pull the data from Snowflake to a local data frame to be processed on local compute. I do local and put that in air quotes because that compute is, in this case, would be the Databricks Compute. So why don't we go ahead and do that? Go ahead and run this cell, and we'll see how long this takes. So we are queries executed on Snowflake. We're now marshaling that data from Snowflake across the network, across the cloud, and into this local compute. If memory serves me correctly, this is ends up being about 7.5 bytes of data. And again, as a reminder, there will be timestamps for the video down below. Feel free to hover over the progress meter to fast forward if necessary. Okay, about 2 minutes and 69 seconds for that local data frame to be created or populated. Go ahead and take a look at the contents. You can see we've got that local data frame. Take a look at the first 100 records, and we'll get information on that data frame. All right, so we've got 2 columns. See the column types, and memory usage here in local compute is 7.5 gigabytes. So there you have it. A demonstration showing how easy it is to utilize Databricks notebooks, taking advantage of the scalable compute provided via the Snowflake Data Cloud by way of the Snowpark API.